In this video, we're going to take a look at how we can add and subtract fractions that have different larger denominators. The process is still the same, though finding the LCD might be a bit trickier. To find the LCD, it might be better, instead of using mental math, use either the prime factorization method or stack method. So let's see one example where we use each of these to find the least common denominator. This first example would be very difficult to find the least common denominator by just using mental math. So let's try using the prime factorization method. Recall, the prime factorization method requires us to find the prime factorization of 24 and 60. 2 goes into 24 12 times, into 12 2 times. 2 goes into 12 6 times, and 2 goes into 6 3 times, and which divides by 3 1 time. And so we get the prime factorization of 2 cubed times 3. Similarly with 60, 2 goes into 60 30 times, which is divisible by 3 10 times, which is divisible by 2 5 times, which is divisible by 5 once. The order doesn't matter that we divide them out. We've got two 2's in there, so we'll say 2 cubed times, squared. 2 squared times 3 times 5. And then we can identify the least common denominator, or least common multiple, by using all the factors with highest exponents: 2's, 3's, and 5's. The only exponents we have are on the 2's, and the highest exponent is a cubed. 2 cubed is 8 times 3 times 5. 8 times 3 is 24 times 5. 24 times 5 is 120. Our least common denominator for this problem is 120. So we want to build up each fraction to 120. What do we have to multiply 24 by to get 120? We multiply it by 5 in the numerator and denominator. This gives us 55 over 120, plus, what do we have to multiply 60 by to get the denominator we want of 120? We multiply by 2 in both the numerator and denominator. 2 times 9 is 18 over 120. And finally, 55 plus 18 is 73 over 120. This fraction doesn't reduce, and so we have our final solution. This method works just fine, but there's an interesting result if we were to use the stack method on a problem instead. Let's use the stack method to find the least common denominator of 12 and 20. They're both divisible by 2, which gives us 6 and 10. And those are both divisible by 2, which gives us 3 and 5. There's now nothing left that divides into both of them. Here's what's interesting about the stack method. To get the least common denominator, we will multiply 12 times 5. But what's even nicer is the fraction with 12 needs to be multiplied by 5 over 5. It tells us the number we need to multiply by. 5 times 11 is 55, and 5 times 12 is 60. The other diagonal tells us what the other fraction needs to be multiplied by. The fraction with 20 needs to be multiplied by, diagonal from it, 3. Whoops. I don't know why it's doing that. There we go. So we'll multiply this guy by 3 over 3, and that'll give us minus 9 over 60. And we would then be ready to subtract. 55 minus 9 is 46 over 60. And then we can reduce that fraction by dividing both by 2, which will give us 23/30 for our final solution. So we find if the denominator is too big to find mentally, we simply use another method, whether the prime factorization or the stack method. Stack method's nice because it tells you what to multiply by, to find our common denominator.